Okay, all right, let's try some examples. We're mostly going to do examples with mean value theorem, but I also, so that's what we're going to see here, and then I'll show you an example at the end of how they go hand in hand. So let's try this one example. So mean value theorem, you can use the shorthand MVT, and intermediate value theorem, you can use the shorthand IVT. They are accepted on the AP test if you are using these theorems. Okay, let's finally try an example. So number one, it says find all values guaranteed by the mean value theorem for this function. So what we just did in our activity, let's connect the activity. In the activity that we did, we had a bunch of graphs. So if I were to graph this function and look at the graph from 1 to 4, draw the secant line from 1 to 4, what I'm doing is I'm trying to find at what value will the derivative be the same as the secant line. Okay, so that's graphically what's happening. I'm showing you now how to do it analytically. Okay, so the mean value theorem says that I want the average rate of change to equal the instantaneous rate of change. But before you ever apply the mean value theorem, what must you test? It has to meet what conditions? The function must be
differentiable and continuous.
Differentiable and continuous. Now we're focusing on the function or the interval from 1 to 4. If I didn't give you that interval, is this function continuous everywhere? No. Where is this function discontinuous?
0.
It's at 0. Okay. However, is 0 in my interval? No. So on the interval from 1 to 4, is this function continuous? Yes. Okay. So we can state that. So we can say f of x is continuous on the closed interval from 1 to 4. So whenever you apply the mean value theorem, you must state that. Now, just looking at the function itself, this is not a polynomial. So I also have to adjust or address the derivative and see whether the derivative exists. So to tell whether a function is differentiable, not by looking at a graph, you find its derivative function. If the derivative, so listen to this really quickly. I'm going to actually write it down. If the derivative function, we'll say f prime, this is important enough for me to write down. If the derivative function f prime is continuous, then f is what? If the derivative function is continuous, then what do we know about the function?
It's differentiable.
It's differentiable, which is also continuous. Yeah, so if f prime is continuous, then f is differentiable and therefore also continuous. And therefore also continuous. That's an important concept. Okay. So what I'm going to now do is I'm going to find f prime. F of x we can rewrite as 4 over x, we can say is 4 times x to the negative 1. So now let's take that derivative. It's going to be 4x to the negative 2, or 4 over x squared, correct? So that's f prime is 4 over x squared. So if that function's continuous on the interval, that means f is differentiable on the interval. Is f prime continuous from 1 to 4? Yes. It also only has the discontinuity at 0. So what that means is f prime is continuous, but what I want to actually state is that f of x is differentiable on, and if I was doing the actual theorem, I would say the open interval from 1 to 4. You've got to make those two statements. If you do not make those two statements, then you will automatically lose a point for justification. So now I know the mean value theorem applies. So now I want to find at which point from 1 to 4 is the slope of the tangent line equal to the slope of the secant line. So I need to first find the slope of the secant line, or the average rate of change of f of x on the interval from 1 to 4. How you state that. Oh, this is important. If this was free response, you must write down what I'm about to write down. Okay? It's f of 4 minus f of 1 over 4 minus 1. You must write that down. Do you all hear me? If you do not write that down, you will actually lose a point because you got to show exactly, it's called the difference quotient. You got to show what you're actually doing. Now we can evaluate. If you just go straight to the answer, if you do this all in your head and you go straight to the answer, you will lose a point. Okay, so can someone tell me what f of 4 is?
4.
4. What's f of 1?
1.
1. So we have 4 minus 1 over 4 minus 1, which is, of course, 1. So if we drew this out, we drew the slope of the secant line is 1. Okay, I want to now find when is my derivative equal to 1. So since my derivative function is 4 over x squared, what we actually do is we say f prime, we actually use c. I want f prime of c to equal 1. That's the whole goal with the mean value theorem. I want f prime of c to equal the slope of my secant line. So what we do is we plug in c into my derivative function and we solve. So c gives me values of plus or minus 2. So is that my answer? Positive and negative 2? No. Why, Grace?
Because your interval's only...
Perfect. Yeah, your interval's only from 1 to 4. So negative 2, you do have a slope of 1 there, but I only care about the interval from 1 to 4. So we cut out, so negative 2 not in interval. So c equals 2. Okay, so we've looked at the mean value theorem graphically. That was at the start. And now we've looked at it analytically, how to do this algebraically.